Hello and welcome to the series of Educating Pi projects. Firstly, let me introduce you to the Raspberry Pi Revision B. Let's start by running through the main parts of this mini computer. The Pi Central Processing Unit is an ARM 700 MHz processor. This reliable processor is used in many popular devices such as smartphones, including Apple and Nokia phones. Looking at the components around the outside of the Pi, first of all we have the audio jack socket for connecting speakers or headphones. We then see the composite video output socket, allowing the Pi to display on typically older design video devices, for example digital projectors and televisions. Moving to the power input, to plug the Pi into a mains electricity supply with the included power adapter. Next is the HDMI connector. HDMI is the most common method to connect the Pi to display devices with HDMI sockets, such as modern computer monitors and televisions. Note that HDMI connections can carry both video and audio signals. Looking at the connections at the end of the Pi, we have a standard RJ45 network port. Use this to connect your Pi to the local IT network or direct to a PC using a network cable, such as that included in the kit. In these projects, we will show the Pi display output and control the Pi by directly connecting a computer to this network socket. Next to the network port are two USB ports. A keyboard and mouse can be connected here, or a memory stick, which is very useful for transferring files to and from the Pi. Turning the Pi over, we see the SD socket, able to accept most standard SD memory cards. The operating system for the Pi does not reside on the Pi itself, but uses an SD card as a drive to host the operating system from which to boot. Finally, we look at the GPIO pins, which stands for General Purpose Input-Output. These pins are fundamental for using the Pi as a device controller. The 26 pins indicated have different functions, but the most important for the Educate Pi projects are those listed as GPIO. These can be turned on or off individually using programming code in a language such as Python, so controlling electronic devices and components. The GPIO pins can also detect an incoming signal, allowing monitoring of what an electronic device or component is doing. The pins are assigned numbers, with pin 1 at the top right in this view and zigzagging sequentially as shown. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. It is important to remember the position of pin 1 and how the pin numbering works for the Educate Pi project. So now, to get the Pi up and running, first take the SD card which comes with the kit. This holds the pre-configured Raspbian operating system from which the Pi will boot. Turn the Pi over and push the card into the SD slot. Turn the Pi back upright and take the included network cable. Plug one end into the computer, which will be used to access and control the Pi, and the other end into the network port on the Pi. Make sure it clicks into place. Finally, plug the included power supply into the mains and connect to the Pi. When connected, you will see the LEDs in the corner light up, showing that the Pi is on and booting up, and has a successful network link to the computer. You're now ready to have some fun with the Educating Pi projects, so have a look at the project videos on the DVD.